Alright guys, so today we're going to be talking about rationalizing the denominator, and when we do this, we're simply just getting rid of the square root in the denominator. Alright. Now before we do this example problem, why don't we go ahead and talk about why do you want to rationalize the denominator. So for example, if you had 1 over the square root of 2, this is going to be equal to the square root of 2 all over 2. So notice here, right, my square root is in the denominator, here is in the numerator. Now if I were to go ahead and write this out, what would I get? So looking at this guy right here, I have 1 over, and we know the square root of 2, okay, is going to be the following. We have 1.414, right, 213, and then 562, again, this continues on, right, it's irrational. Same thing over here, right? I'll have the same number, except now, right, it's in the top, 1.414, 213, 562, right, all over 2. So, back before they had calculators, right, and tools for calculating, you would have to do this by hand. So, which one would you rather do by hand? 1 divided by this big irrational number, or the irrational number on top divided by 2, right? This one right here, right, is going to be much easier, right, and much cleaner, right? So that's where rationalizing the denominator comes from, and that's why you want to do it, okay? So again, mathematically, you want to have the square roots in the numerator, not the denominator, okay? So let's go ahead and work on this problem here. So we know that we have to rationalize the denominator here. Right, so we need to get rid of this square root of 4. Now, in order to do that, we're going to multiply both the bottom and the top by the square root of 4. Right? And we do this because we know that when we multiply two square roots that are the same, right, we're simply going to be left with what's underneath the radical. In this case, we'll be left with just 4. So the square root of 4 times the square root of 4 is simply just going to be 4. Okay? So in our denominator here, we just have 4, okay? And then we have the following, right? We'll have 3, and then we'll have the square root of, and 7 times 4 is going to give us 28. However, we're not done, because notice this square root of 28, okay? We can actually go a bit further, all right? So if we go off to the side here, right, and I write the square root of 28, well, what's going to be the biggest perfect square that is a factor of 28? Well, that's going to be the square root of 4. And we just multiply by the square root of 7. And we know that the square root of 4 is 2. So we're left with 2 square roots of 7. Now just combining, okay, what we have on the top here, so we have 3 times 2, which gives us 6. So we have 6 square root of 7 all over 4. And at this point, we can go ahead and reduce, right? We know that 2 will go into 6 3 times, so we can write 3 square root of 7 all over, and 2 goes into 4 2 times, right? So this here is going to be your final answer. All right, let's try another example. All right, guys, so here is our next example, and this one is a bit more challenging. Notice that we don't just have a square root now, we have 5 plus the square root of 2, right? So in order to do this, go back and think about the difference of 2 squares. So just using an example here, if I were to do x plus 2 and x minus 2, right? What happens here when I go ahead and do this out? Well, I'm going to get x squared, right, when I do first. And then outside and inside, right? Well, those terms are simply going to cancel, right? Because I'm going to have a negative 2x and a positive 2x. That cancels, and then you get stuck with minus 4. We call this a difference of 2 squares, right? So think about how you can apply that same kind of principle to this problem here, and how you go about doing this, okay? So I know on the denominator here, I have 5 plus the square root of 2, all right? Well, if I multiply both the bottom and the top by 5 minus the square root of 2, right, times 5 minus the square root of 2. Let's see what happens in our denominator. So again, using FOIL here, we do first, we get 25. Okay, again, outside and inside. That's simply going to cancel because again, I'll have negative 5 square root of 2 and positive 5 square root of 2, right? It just cancels out. And again, if you want to write it, you can. So minus 5 square root of 2 plus 5 square root of 2, right? We can see that these are going to cancel. And then we know that the square root of 2 times a negative square root of 2 is just simply going to give us negative 2. Right? And at this point, we just can combine our like terms, which we have here and here. So we're left with 23. So we have 23 in the denominator. And if we look at this right here, right, well, all we have to do is distribute, right, this 7 to each one of our terms. So we do 7 times 5, we're going to get 35. So we'll write 35. And then 7 times a negative square root of 2 will give you negative 7 square root of 2. And this is all going to be over 23. Okay? So in this case, we just went ahead and rationalized the denominator. This here would be your final answer. Okay? All right. And that is it.